In this video, we will show you how to build a secure backend that scales based on the design of your web app. Looking at a design in Figma, we'll decide what pages we need to create in our front end and whether they need to be public or private, what information we need in our relational database. We'll use Xano as an example, but the logic will be the same no matter what backend you choose. And how we want our user interface and backend to interact with each other. In other words, what API calls do we need to make and how should we protect them to ensure our data is secure? As you know, WeWeb is focused on the front end, so we'll stay fairly high level, but we thought it would be helpful to you if you're trying to build an app that scales to get an introduction to database design and how to structure your backend. Don't worry though, we've also made a Xano snippet for you, so you don't have to build a backend from scratch. You can just use our Xano snippet to start building in WeWeb using the backend we created for you. If you're watching this on YouTube, the link to the Xano snippet is in the video description. If you're watching this in the Academy, the link is on the course page. Let's start by looking at our design in Figma. So what do we have here? In Figma, and we're using Figma, but it could be any other design tool, we have a list of colors that we will be using throughout our app and a list of typographies. And we also have all the screens for our app. So we will be building a ticketing app where a user needs to be logged in to view their tickets, and then they can edit a ticket or they can create one. And if they're an admin, they have a little admin section here where they can see all the tickets of all the users, and they can also edit the ticket through this page. Taking the time to mock up your app in a tool like Figma or another design tool is very useful. It will help you understand what you need in your database and how you need to structure it. We highly recommend that you start by designing before you even think about building in WeWeb or building in Xano or whatever front end or back end you're using. It's very important that you start with a design because it will help you build a user experience that is fluid and that makes sense. So once we have this, we're looking at this Figma design. How does that help us structure our database? Well, it helps us structure a database because the design that we created up front will help us decide what pages we need in our front end, what information we will need in our database, and what API endpoints we will need to make sure that our user interface, our front end, can interact with our database, our backend. So let's start with listing all the pages we'll need to create in WeWeb. Here we have a list of user tickets. So it says My Tickets. Let's copy paste this template and say user tickets. And we see here that the user needs to be logged in. So this page we can assume will be private. What other page do we need? We need a page for the ticket page where users will be able to update a ticket. And we can say maybe ticket/ID. And again, it will be private. We also have a create ticket page. And the design, it looks like this will be the same page whether we're creating a ticket that is a sales question or product feedback or a bug. So let's say new ticket. Does it need to be private? Maybe not. Maybe the user will be able to enter their information. Though if we want them to be able to see their tickets afterwards, we probably want them to be logged in when they create the ticket so we can pass through a user ID. So let's keep it private. What else do we have? We have the all tickets page for admins. So all tickets. And again, the access is private. And it's also admins only. So for the user tickets, the ticket ID, and the new ticket, the access is for authenticated users. Okay, and I also have a permissions page. Let's have it here. Permissions. And it's also for admins only. I can see that here. It's in the admin submenu. Okay, is that all? Yes. And there's one thing I can tell is missing from my design is a login page, because all of these pages are private, but I still need my user to be able to log in at some point. So I will create a login page, and that page will be public. It will be the entry point for all of our users. Now that we know which pages we'll have in our user interface, let's ask ourselves what information on those pages will come from the database and what information will be hard-coded in the front end. Let's start by looking at the user tickets page. On this page, I see different types of information. I see information that is related to the user, and I see information related to tickets that I can search and filter with select elements. And I see here 5 tickets, so I suspect this will be dynamic and this will change frequently. So the user can change and the tickets that will appear on the page can change. I also have information that seems pretty static. It doesn't seem like it's meant to change at any point. I mean, this is the name of my app. This is a button that will always allow me to create a ticket. I have a navigation menu, and maybe the admin links will not be displayed when a user who is not an admin is logged in, but the text is not meant to change. I don't need to get that information from my database. So based on this analysis, in my database, I should have 2 tables: a user table with information about my user and a ticket table with information about my tickets. Let's write this. So I'll copy paste my template. Table name will be user. And the information I need is the email address, and also the name. And so these 2 will be text fields, or strings is another way of saying the same thing. And that's it for now. That's all the information related to the user. Now I should also have a table with information about tickets. Let's create it. Okay, so ticket. In the fields, I will need a title, I will need a status, and I will need a type. So okay, at this stage, it's all the information that I know that I need in my database. Let's have a look at the other pages to see if there are other tables I need in my database or other information I need in the tables that I already mapped out. So on the ticket page, it looks like I have more information. So here I still have the status, the type, and the title, but I also have a description, project link, video link, and screenshots. So let me add this information to our little post-it. Video link will be a text because it's a URL. Same with the project link. But the screenshot links will be an array in our database because the user may upload one or several files. So we need to be able to have a list of items. Even if there's only one screenshot, it will be one screenshot in an array. So an array with only one item. Okay, the last thing we have here is a comment. In our ticket table, we will add a column with comments, and it will be a related field to the comment table. And it will be an array because it could be a list of comments. So we will create a comment table. Comment. And for now, the only thing we will have is the comment itself. So what we see here. But if we look at the admin section and how to update a ticket, we see that we also have an on-off toggle and a color. So let's add that here. So display, and it will be a Boolean. So it will be true or false. And also a color, and that will be text. Okay, so now let's have a look at the create ticket page. We have name and email. We will already have this information because the user will be logged in. So this will be pre-filled. We have the title of the ticket and its description. So nothing new here. And here there's a this is needed soon checkbox. So we will need to add that to our table, our ticket table. So let's add it here. Will be again a true false. Let's see if there's anything else. No. And if I look at final one, explain why this is so urgent. So if someone checks the this is needed soon checkbox, we need more information. So let's add it here. Urgency. And that's it. Now, let's see what that looks like in Xano. In my database, I have the three tables we talked about: a table with the user, their name and email. It was not in my design, but there will be a password field that would have been obvious if the designer had added a login page in the Figma file, but for now we don't. There's also a role which I forgot to map out when in here, but I can clearly see in my design because there is a section for admins, so I can assume that there will be admins and non-admins. So I've added it here, and in Xano I have this column. This is a column for magic link, which will be helpful when we set up a forgot password flow. So this is my user table. Then I have my ticket table with all the information that we discussed. So you see here that there are texts, and then here is an array for the screenshot links, a Boolean for the needed soon field, and a reference field to the user, and also a reference field to the comments. So the reference field to the user ID is also something that I forgot to add here. And I should have known better because I mentioned it several times that this page was related to this user. So these tickets are related to this user. So in my table, I need to know which user owns the ticket. And finally, in Xano, I also have a comments table with the information, the Boolean of whether I should display it or not, the comment itself, its color, and in this case, I've also added a user ID. It's not obvious from our design in Figma, but we can anticipate and imagine that it will be helpful to us to know which user posted a comment. Now let's take a step back. Why did we choose to create three separate tables? Why didn't we just add a couple of columns in the tickets table with their username and user email? And why didn't we just add all of the information about comments in the comment column of the ticket table instead of having a dedicated comments table? In both cases, the answer is scalability. In database design, when choosing which tables to create, how to organize your data, it is best practice to create one table per topic. So you want to group related information together in the same table. For example, product tickets in one table and users in another table. It's best practice to create two separate tables when dealing with two separate topics and linking using reference fields to link both tables, like we did with a link to the user ID and a link to the comments IDs. This is important because it makes it easier to address two key database design requirements: reducing duplicate information and ensuring the accuracy and integrity of your data. And both go hand in hand. If you have duplicate information like a user email address in a user table and in a ticket table, for example, if the user updates their email, you may forget to update their email address in the ticket table. Maybe you will make the update in the user table, but forget to make it in the ticket table. And even if you didn't forget, it would not be efficient at all. It would be redundant and inefficient to update the same information in two places. Much more efficient and much more risk-free to update it in the dedicated user table. And then all the tickets for that user will be clean because the reference field, the user ID, will not have changed, but will refer to up-to-date information. All right, now that we know what pages we'll need in the front end and what information we'll need in our database, we need to figure out how our front end and our database will communicate. How will my UI interact with my backend? The idea here is that we will once again look at our design to understand what API requests we need to make in the front end in order to get information from the backend back to our front end. So if I look at Postman's documentation about APIs, I see there are four main requests, API requests. There are GET requests to get data that will be displayed in the front end. There's the PUT request, which is updating an entry in the database. So when the record already exists in the database, but we are updating it. So in our design, that will be the update ticket page in modal, for example. We have a post request verb, which is to create a new entry in the database. So in our case, that will be the create ticket page. And a delete request to delete an entry from the database. So get, put, post, and delete. There are others, those are the four main ones. Back in our design, let's look at our first page, My Tickets. So what do we need here? We need the list of tickets that belongs to this specific user. We need to get that information. We're not changing it, we're not deleting it, we're simply reading it. So back in our board, we will copy paste our API call template, and we will say we will get user tickets. The user will need to be authenticated, and it will need to be the current user or an admin. So when trying to access a list of tickets related to specific users, only users with an admin role or that specific user will be able to access those tickets. We don't need any inputs, and in terms of output, if we look at our design, we want the title, the status, and the type. So title, status, and type. And by the way, we could have inputs. We see here that we have a search bar and we have select elements. So we could send this information as inputs to the backend in order to filter the tickets that match those conditions and only fetch tickets that match those conditions. In this case, for this page, for the user tickets page, we will do these filters in the front end because we don't expect there will be many tickets per user. But when we start working on the admin page where there might be hundreds of tickets, maybe even thousands, then we will consider filtering in the backend. We have discussed at length the benefits of filtering in the front end or the back end, depending on the use case, in the Build an MVP course of the WeWeb Academy. If you're not familiar with those videos, I highly recommend that you check them out. In the rest of this course on how to build a secure web app that scales, we will go into detail on how you can implement those front-end and back-end filters. We will implement front-end filters for the user ticket page and back-end filters for the admin all tickets page. Okay, back in our design, we're now in the update a specific ticket page. So in this page specifically. Now, in this case, we will need to do two things. First, we will need to get the information that is displayed on this ticket page. So if we want to be able to view this, which will be pre-filled, or view the information about the ticket and its comments, we need to get that ticket from our database. So let's do this. Get ticket, and it will be ticket ID. This is in between curly brackets because it'll be a variable, it will change. The user will need to be authenticated, and it will need to be the owner of the ticket or an admin. And the input will be the ticket ID. And as outputs, we will need the title, status, let's say type, and if it's pre-filled, we'll have description, video link, project link, screenshot links, comments, and that's it. Okay, now we also want to allow users to update this information. So this information will be pre-filled when they first come to the ticket, but they might need to update the project link or video link. Let's take this and copy paste it. And now instead of a get, it will be a put. And here, again, the user will need to be authenticated, and only the owner of the ticket or a user with the role admin will be allowed to update this ticket. Again, we will have the ticket ID as an input because we need to tell our backend which ticket ID we want. But we will also have all of this as an input in case the user wants to update either one or all of these fields. This is the output that we want to display in our front end, but our backend will actually return more information like the user ID, whether the ticket is needed soon or not, all that information that we listed in our ticket table. Our backend has the potential to return it to us. So we can decide later if we want to limit the output to only the information that we display on the page. For now, we'll leave it. We'll list everything that we're sure we want to display on our page. But just so you know, in Xano, by default, the output will include all the fields from your table. All right, back in our design, let's have a look at the create ticket page. Here, we will display the name and email of the user who is currently authenticated. We will already have had that information. And we will want to be able to post to create a new record. So, title, message. Let's go ahead and copy this one. All right. Now it's a post request and it's simply ticket. So the user will need to be authenticated, and that's it. They only need to be authenticated. They don't need any special user role or permission. In terms of input, they don't have to input a ticket ID. That will be created by default. So they'll need a title and a description, which we see here. And we will also be sending the information about the user. Now remember, in our ticket table, we don't have a name and email field. What we have is a user ID. And the user ID is related to the user table where we have that name and email information. So we don't need to send this information. What our ticket table expects is a user ID. There we go. And the last piece of information we need to provide to our backend so it can create the record is the type of ticket. So here it would be a sales question. Okay, what about our product feedback? There would be additional input like if it's needed soon or not, and also description, project link, video link, screenshots. So needed soon. That's it. And let's say that the user said, yes, it's needed soon. Then we need to add the information about whether it's urgent or not. So in the input, we will also add that urgency message. And we can just, by default, copy paste. We expect the output will contain all of the information we sent back. This is just the preliminary work for our project. Further down the line, we can decide to optimize our inputs and our outputs further. Okay, back in our design, let's have a look at our admin page. In this design, we chose to have two separate pages, one for the user's tickets and one for the admin's tickets. We could have decided to have a single page and a single API endpoint where, depending on if the user was an admin or not, we displayed certain tickets or not. In this case, we decided to have two separate pages where we get tickets. In one page, we get the tickets of the current user, and in another page, we get the tickets, all the tickets for admin users. We went with the approach of having two API calls, one to get the tickets of the current user and one to get all the tickets for admins. As with many things in web development and programming, you have several options available to you. This is the option we chose because we believed it would be more maintainable and thus scalable down the line. It would also be easier for people to work on the project, to see those different pages and those different endpoints. We thought it would make their lives easier. The other option would have been to have one big endpoint with a more complex function stack in Xano. We decided against that approach because we thought it would make it more difficult to maintain down the line. But it can be a question of personal preferences. So if you have a preferred approach, don't get bogged down by what we're saying here and go with the approach you prefer. If you don't have any preferred approach, then follow along and hopefully learn along the way. Back in our board, let's copy the user tickets endpoint and paste it here. And here it will be get all tickets. And yes, the user will need to be authenticated and they will need to be an admin. They will not be able to access this endpoint if they're not an admin. Now, on our My Tickets page, on our user tickets page, we decided against inputs. In this case, we will add the search, select type, and select status. Remember here we have a search bar and two select elements that allow the admin user to filter through all the tickets. Now, because we expect this list of tickets to be very big, we will do our filtering in the backend. And so if we want to filter in the backend, we need to tell the backend what the value of the search is, what value of the select type is, and what value of the select status is. That way, our backend can return the tickets that match those specific inputs. That's why we add inputs here, to be able to add backend filters. In terms of output, we want to display the title, the status, the type, and also an information as to when it was created. Finally, we'll want to add an endpoint so admins can add comments or delete comments on a ticket. We will want to create endpoints to add, modify, or delete comments. And we will also want to update our update ticket endpoint to send the IDs of the comments related to the ticket. First, let's start by creating comments. Here we will post comment yes, and there will need to be an admin. The input is just the comment itself, the color, display, and that's it. The update to the update ticket endpoint will be here in the inputs. We actually already have the comment IDs, so comment IDs would be more explicit. And here we posted a comment. We can also use exactly the same structure as a put to update a comment. We see here in our design a little autosave for comments. And we can also delete. So in this case, there will be comment ID. And the inputs would be, well, the comment ID. Comment itself, the color and display, which can all be modified. And here, if we wanted to delete a comment, it would be the delete verb, comment in comment ID. And here we would just need the comment ID. And our output here would be nothing really. I mean, it would be, our backend would send no data back to us. It would return a message telling us that our API call was successful, but it won't return any data since we deleted the record. Finally, the last page we need to look at is this page with permissions. It's our little admin where only admins can view users and they can change their roles. They can edit a user's name or email or role. So this page here is the first point of failure of your web app in terms of security. You want to make sure that you create an endpoint that is dedicated to admins so that if a user doesn't have the admin role, they would at no point be able to update a user's record. Because otherwise, what they might do is they might simply make themselves an admin. An easy way to hurt a business would be to create a user account, make yourself an admin, and delete all of their data. So you want to make sure that doesn't happen to your business. So we'll create a specific endpoint that is a put verb, a put request, and we can call it permission user ID. So this is to update a user. You need to be authenticated and you need to be an admin, otherwise you can't. As an input, you have the user ID. You also have the name, email, and role. And that's why you really don't want to mess this up. And the output would be the user record, really. I'll just type it in instead of pasting all the information from the user table. Okay, and actually, even before we update the user, we need to be able to get this data to display it on the page. And again, we want to make sure that this is an endpoint that is reserved to admins, so that only admins can access the list of users of our business. Otherwise, there's a real big privacy issue. Okay, in this case, we will get this and paste it. And now it will be a GET request, and we won't need a user ID since we're getting all the users. And again, what's very important, the user needs to be an admin to have the role admin in order to be able to do that. And that's it. We don't have any inputs, there are no filters, and the output will be a list of users with their name, email, role. That's it. A pretty thorough walkthrough of how to think about your front end and back end when looking at the design of your web app. In other words, what pages do you need on your user interface? What information you need in your database? And how can the two interact? What API calls do you need to make? How do you need to protect them? What API calls do you need to make? How do you protect them to keep data private and secure? How do you filter data to improve the performances of your app? These are all questions that you need to ask yourself throughout the project, but it really helps to take the time at the beginning of a project to think things through and map out what you need before you start coding or no coding with tools like WeWeb and Xano and Supabase and others. There was a lot of information, but please don't hesitate to consult the handbook that comes with this course. If you're watching this on YouTube, it is in the video description. If you're watching this on the WeWeb Academy, it is on the course page. Please check it out. Go through the key takeaways, go through the mirror board, the Xano snippet. All of that will help you a lot. It may take a little bit of time at first, but you won't be sorry in the long run.